In this video, we'll do a nice triple sum problem, so we'll evaluate the inside out. So we have the sum from n equals 0 to 10 of the sum from k equals 0 to n of the sum from I equals 0 to k of r to the I. So we use parentheses like this, so we evaluate the middle part first. So let's do that. So we have the sum from I equals 0 to k of r to the I. We can think of this as I going from 0 to infinity first. Then we have to subtract the parts that it's bigger than k. So r to the I minus now the parts that it's bigger than k, namely it starts at k plus 1. So it's the sum from I equals, not 0, but k plus 1 to infinity of r to the I. And now because it's infinite sums, technically it has to work for only specific r values, but in this case we can put it together at the end and then it'll work for every r value. Okay, so let's do this part first. So the first part is to plug in the first term, which is I equals 0. So r to the 0 is 1, all over 1 minus the ratio, which is r, minus, for this part, do the same thing. So we have r to the first I value, which is k plus 1. So we have r to the k plus 1, all over 1 minus r. We can put it together, so we have 1 minus r to the k plus 1, all over 1 minus r. Now we can multiply by negative 1, so it looks better. So we have r to the k plus 1, minus 1 all over r minus 1. And now this is 1 over r minus 1 is a fraction. Under sums, we can just bring it to the front. So we have 1 over r minus 1, and then we're going to repeat the other two sums. So we have the sum from n equals 0 to 10 first of the sum from k equals 0 to n of the part we just found, which is this. So that will be r to the k plus 1 minus 1 in parentheses. Okay, so this will be 1 over r minus 1 times the sum from n equals 0 to 10. And now we're going to write a bracket. So the first thing we have is the sum from k equals 0 to n of r to the k plus 1. And r to the k plus 1, we can write it as r to the front times the sum. Okay, and then we're going to have minus 1 under k going from 0 to n. So this we can just write it down again, 0 to n of just 1. Okay, but what is this? So this will be, you're adding up 1 how many times? So it would be n plus k, which is n, or n minus k, which is 0. So it would be n plus 1 times. So this will be n plus 1 times, but times 1. Okay, so what does this will be? So this will be minus parentheses n plus 1, which can be rewritten as minus n minus 1. Okay, good. Okay, what else do we have? So we have 1 over r minus 1, and we have the sum from n equals 0 to 10. Okay, so for this part, we kind of just did the same thing here. So the sum from r going from I equals 0 to k, and you get r to the k plus 1 term minus 1 over r minus 1. So over here, you're going to get r times something. So in this case, you'll get 1 minus r to the n plus 1 all over 1 minus r, because n is the last variable. And then we're going to have minus n minus 1. Okay, good. So now we can split these up again. So we have, so for the first part, we have r over r minus 1 times r minus 1. So actually, I wrote that wrong, but it's r minus 1 because the negative sign. So it's r to the n plus 1 minus 1. Okay. So r minus 1 times r minus 1 is r minus 1 squared. Then we'll have the sum from n equals 0 to 10 first of just r to the n plus 1 minus 1. And then we'll have minus, so we can write this actually as n plus 1 in the parentheses. So this will go, okay, so this is 1 over r minus 1 times the sum from n equals 0 to 10 of n plus 1. Okay, good. But we can move n plus 1 back to n. So this will just be, so instead of going from 0 to 10, we'll have 1 to 11. Okay. And what is this? So this So we know that the sum from n equals 1 to capital N of just n will be capital N times capital N plus 1 all over 2, which is an identity. So this will be equal to 11 times 12 divided by 2. 12 divided by 2, we can simplify first to be 6 times 11 is 66. Okay, so we're going to have r over r minus 1 quantity squared. Okay. So now let's do this first. Okay, so now we're going to take out an r first from this part. So we're going to split this again. So we're going to have the sum. So we're going to have r times the sum from n equals 0 to 10 of r to the n minus 1. So minus 1 from 0 to 10, but that would be 11 times. So this would be 11. Okay. And then from this part, we're going to have 66 minus 66. So we're going to have minus 66 all over r minus 1. We can ignore this part. Okay. Okay, good. So now we're going to have, let's see, we're going to have r times r, which is r squared over r minus 1 squared. So for this part, how do we do this? So like before, this will be r to the whatever's here plus 1. So this will be r to the 11 minus 1 over r minus 1. And then we're going to have minus 11 r over r minus 1 quantity squared minus 66 over r minus 1. Okay. So r minus 1, we can combine again. So we have r squared over r minus 1 cubed times r to the 11th minus 1 minus 11r over r minus 1 squared minus 66 over r minus 1. And that is the end of the problem, and that's the end of the video. Hope you liked it, and thanks for watching.